Good morning, students of grade 9. Today we will start an second lesson number 2, force. Let us first define force. Okay, you know that force is defined. Once again, remember, take your copy and pen in front of you, and whatever I'm writing, write it down. Force is defined as an external agent that changes or tend to change the state of an object from rest to motion or motion to rest. Okay, now suppose that this pen, you can see it is not moving. That means this pen is in the state of rest, and it will not move until I apply an external agent. That external agent that I apply with my finger, yes, that external agent that moved it from a state of rest to state of motion, then that agent is called force. Now if you apply force on a wall, then the wall does not move, and yet you are attempting to change its state from rest to motion, so that is also force. While applying force, it is not necessary that the object should move. Okay, if the object moves, then work is done. If the object does not move, then work is not done. And however, there is force, and you all know what is SI unit of force is. SI unit of force is Newton. This one we have studied in first lesson as well. Okay, since we defined force in terms of state of motion or state of rest, let us discuss about this. What do we mean by motion and rest? Now let me ask you a question. You can see here, this is a house. Okay, this is a house, and here we have a tree. Okay. Now tell me, is this tree in state of rest or in state of motion? If I ask you, is this tree in state of rest or is it in state of motion? How do you define whether it is in rest or motion? The first criteria is we need to see if it is moving or not. And how do you know if it is moving? We know that by comparing it to another object, which is known as reference object. We need a reference object or reference point to compare the movement of this object. Okay. Now in reference to the house, the tree is definitely not changing its position. Okay, that's why in reference to the house, the tree is in state of rest. Okay, the tree is in state of rest in reference to house. But think of it as a whole. This whole structure is on the earth, isn't it? The whole structure is on the earth, and you know that the earth is rotating in its own axis. Okay, it is rotating in its own axis, and at the same time it is moving or it is revolving around the sun as well. That means it is revolving around the sun. Now my question, if the earth is in constant movement, then how can this tree which is on the earth be in state of rest? See, it is quite confusing. Yes, in reference to house, we obviously see that tree is in state of rest, but since the tree lies on the earth and the earth is rotating in its own axis, or it is revolving around the sun as well, that is, earth is in constant movement, then the tree on the earth must also be in constant movement or constant motion. That's why if we take the sun as a reference point or other stars or planets as a reference point, then the tree is in state of motion. In state of motion in reference to let's say sun. Now see, it shows that same object can be in state of both rest and motion at the same time. Same object can be in state of rest and motion at the same time when different points are taken as reference. Okay, so the tree is in state of rest when the house is taken as reference, and it is in state of motion when the sun is taken as reference. So motion and rest motion and rest are only a relative term. Relative term means without comparing it to other object, we cannot tell whether an object is in state or a state of rest or motion. That means because without comparing to other object, a state of rest or motion can not be determined. This is one reason, and another reason is same object can be in state of rest and motion at the same time when different object is taken as reference. Okay, motion and rest are relative terms. This is important question. Motion and rest are relative terms because without comparing to other objects, state of rest or motion cannot be determined. First reason. And the second reason, same object can be in state of rest and motion at the same time when different objects is taken objects are taken as reference. And its example is here. The tree is in state of rest in reference to house, but it is in state of motion in reference to the sun. Now, how to define rest and motion? We have done this in grade 8. We are just revising. Rest, when an object does not change its position with respect to a reference point. It's called rest. And what do you mean by motion? When an object changes its position with respect to a reference point. See, if an object does not change its position with respect to a reference point, then the object is at state of rest. And if an object changes its position with respect to a reference point, then the object is said to be at state of motion. Now, let's go back to force. Effects of force. What changes occur when force is applied on a body? What changes are seen when force is applied on a body? Now say, if an object is at state of rest, yes, if an object is at state of rest and you apply force, then what happens? Definitely the object moves, isn't it? The object moves. That means if force is applied, okay, note it down. If force is applied on an object at rest, then the object moves, or the state of rest changes to state of motion. And second point, if an object is at motion, object is moving, yes, if an object is at motion and force is applied in exactly opposite direction, equal amount of force is applied in exactly opposite direction. Okay, then what happens? The object is moving with certain force. Okay, the object is moving with certain force, and if you apply same amount of force from opposite direction, then the object stops. Like let's say this is a pen. It is in state of rest. If I apply force on this pen, then the pen starts to move. But while the pen is moving, if I apply same amount of force from opposite direction, then the pen stops. That is, pen comes to the state of rest. And another effect, let's say the object is at motion. Then in that case, if force is applied in the same direction as the motion, if force is applied in the same direction as the motion, then what happens? Speed increases. This is the third effect. If force is applied on a moving object in the same direction, then it increases speed. And next effect is, suppose the object is at motion, and if you apply force in some different direction, than its motion movement, then the object, it changes direction. Okay, these are four basic effects. See, and first of all, if force is applied on an object at rest, then the object moves. If force is applied on moving object in opposite direction, then the object stops. If force is applied on moving object in the same direction, then the speed increases. And if force is applied on moving object from different direction, then it changes its direction of movement. And next one, let's say you are taking a sponge ball and you squeeze it. What happens? Its shape and size changes because of displacement of particles. So if you apply force on an object, then it can also change shape or size. Okay, these are 5 basic effects of force. Okay, let's discuss next balanced and imbalanced or unbalanced force. Now this, on any object you can see in your surrounding, in any object there is always two kind of force acting on it. On any object there is always two kind of forces acting on it. If the two forces are in opposite direction and they are same in quantity or same in magnitude, then the object does not move at all. For example, look at my hand. There is a frictional force applied by paper on my hand. If I try to move my hand by applying some force, then if the force applied by me is equal to frictional force, I cannot move my hand. If the force applied by me is more than frictional force, then my hand starts to move. Similarly, think about a car. There is residual force, a gravitational force, yes? Okay, gravity attracts car toward the center of earth. That means it provides weight of the car. Because of that gravitational force, the car is not moving. Okay, and along with the frictional force provided by the road or surface also does not allow it to move it. Then you start the engine needs to apply some force to pull it forward. Okay, then if the engine cannot provide sufficient force to overcome gravity, if the engine cannot apply sufficient force to overcome gravity or its weight or friction, then the car cannot move forward. The engine has to apply more force than gravity applied on this car or the friction force applied on this car. That is why a scooter engine of scooter cannot be fitted on a bus. It cannot move the bus because scooter engine cannot provide much amount of force. Okay, by saying that, we have to conclude that if two forces acting on a body are not balanced, only then the body moves. Okay, let's take an example. You all might have played tug of war. In tug of war, two group of players stand on two opposite sides, yes, and they try to pull each other. This group applies force in this direction, and this group applies force in this direction. Now say if both of them are applying same amount of force, this group applied 1200 Newton of force and this group also applies 1200 Newton of force, then what will be the outcome? The rope does not move at all. Okay, neither this team A wins nor team B wins, neither of them wins. The rope does not move at all because same amount of force is being applied on both sides. Now let's say group B applies 1500 Newton of force, whereas group A applies only 1000 Newton of force. In that case, obviously what happens? Group A will be dragged toward group B and group B wins. Or when group B was applying 1500 Newton of force, but group A increased their force and they applied 1800 Newton of force, and in that case group B will be dragged toward group A. So here this also concludes to that if force applied on an object is equal in magnitude but opposite in direction, that means if they are balanced, then the object does not move. However, if the forces are not balanced, then the object starts to move. Now next concept we have is vector and scalar. These are all revision from grade 8. Vector and scalar. What do you mean by vector quantity? Those quantities that have both magnitude and direction, whereas scalar, those quantities that have magnitude but no direction. Okay. Let's say if I need to measure length of this pen, then whether I measure it from this end to this end or whether I measure it from this end to this end, does it matter? No, it does not matter. It gives same reading. So measuring length only involves magnitude, but it does not involve direction. So length is an example of scalar quantity. However, if I need to find out displacement, displacement, say I am in Kathmandu and then I need to go to Bhaktapur. Okay, in this case, what should be my displacement from Kathmandu to Bhaktapur? In that case, I only measure the distance, the shortest distance from Kathmandu to Bhaktapur. But if I measure the distance from Bhaktapur to Kathmandu, it will not be applicable. Okay, it will not be applicable because I need to find my displacement from Kathmandu to Bhaktapur. That's why while measuring displacement, I need to measure magnitude as well as direction in a particular direction. That's why displacement is an example of vector quantity. Now once again, if we vector quantity, what do you mean by vector quantity? Those quantities that have both magnitude and direction. And scalar quantity, those quantities that have magnitude but no direction. Now speaking of magnitude, vector quantities can have positive, negative as well as zero value. But scalar quantity can only have positive value. Now, can I say length of something is 0 meter or 0 centimeter? No. 0 meter or 0 centimeter means the object does not exist at all. Okay, so length of an object cannot be 0. If an object exists, then its length cannot be 0. But talk about displacement. I am in here, I am staying here. From here I move to B, from B I move to C, and then from C I move to D, and finally I move back to A. So my initial position was A. Okay, I changed my position and finally once again I reached A. That means I have moved, but have I displaced? No. My movement is there. I have moved certain distance, but my displacement is 0. Okay, let's say this is 5 meter, this is 10 meter, this is 12 meter, and this is 8 meter. In that case, what should be the distance that I covered? 5 plus 10, 15, 15 plus 12, 27, 27 plus 8, 35. My distance is, the distance covered by me is 35 meter. But what is my displacement? Displacement is 0 meter. I have not displaced at all. So you can see that scalar quantities can have only positive value, whereas vector quantity can have positive, negative, or 0 value as well. Now let's discuss another topic. This is also you are also quite familiar to this topic, speed and velocity. Okay, speed is defined as distance covered by moving object per unit time. Okay, for example, if I say I am moving with the speed of 5 meter per second, what does it mean? It means that in 1 second time I am covering 5 meter distance. Or if you say a bus is moving at 60 kilometer per hour, what does it mean? The bus is covering 60 kilometer distance in 1 hour. And let's say a bus A is moving at 60 kilometer per hour speed, while bus B is moving at 75 kilometer per hour speed. And I can say which one is moving fast? Bus B. Bus B is moving fast because in 1 hour time bus B covers 75 kilometer of distance, whereas bus A covers only 60 kilometer of distance. So speed calculates, or speed determines how fast is an object moving. And to say speed is scalar quantity. While measuring speed, we do not check for its direction. And you already know its unit. Its SI unit is meter per second. Okay, this much you need to know. Now come to velocity. Velocity is not distance. Okay, it is not calculated by distance covered. It is calculated by displacement made by object. Okay, which path does the object cover? It does not matter, but where was the object at initial point and where is the object at final point, that only matters. Displacement made by a moving object per unit time. Okay, example, before example, let's finish this. Displacement is vector quantity and its SI unit is also meter per second. Now I'll give you an example once again. This is location A, location B, location C. Okay, from A to B the distance is 20 kilometer. From B to C the distance is 25 kilometer. Okay, so you can see our total distance is 45 kilometer, but from A to B it is only 30 kilometer. Okay, a car starts to move from A. Okay, it moves from A to B within 1 hour, and then from B to C in another 1 hour. Okay, so here total distance traveled by car would be 45 kilometer. Okay, but displacement made, what displacement is made by the car? See, although it has moved from A to B and then B to C, although it has covered 45 kilometer of distance, but its displacement is made only from A to C. Its initial point is A and final point is C. So its displacement is AC, and that is 30 kilometer. And what is time? Time duration is total of 2 hours. From here 1 hour and here 1 hour. Therefore, its speed would be distance by time. Yes, distance by time. That means 45 by 2. What shall it give? 22.5 kilometer per hour. Its speed would be 22.5 kilometer per hour. But what about its velocity? Okay, I shall do here. Okay, it what about velocity is equals to displacement by time, and you know its displacement is 30 kilometer, time is 2 hour, that means displacement is 15 kilometer per hour. See, the same object can have different value for speed and velocity. In this case, its speed is 22.5 kilometer per hour, but its velocity is only 15 kilometer per hour. Okay, next title is acceleration. If an object is moving with non-uniform velocity, that means the object speeds up. The speed of object keeps on increasing. Let's say from this point it is 0 meter, 1 second time, 2 second time, 3 second time. Here the car in 1 second time it moves let's say 2 meter distance. Okay, in another 1 second time it moves 4 meter distance, and in another 1 second time it moves 6 meter distance. So altogether it has moved 12 meter of distance. See, in first 1 second time it covered 2 meter of distance. In second 1 second time, in second instance, in 1 second time it moved 4 meter of distance, and in third instance in 1 second time it covered 6 meter of distance. So what should be the velocity of car in each instant? In this instant the velocity is 2 meter per second, isn't it? In this instant it is covering 4 meter in 1 second, so its velocity is 4 meter per second, whereas in this instance its velocity is 6 meter per second. See, its speed is moving. Okay, in first 1 second time its speed was 2 meter per second, then it increased to 4 meter per second, and in third second it increased to 6 meter per second. So its speed is increasing, means it is moving with non-uniform velocity. The car is moving with non-uniform velocity, and notice most of the object in our daily life move with non-uniform velocity. Example of uniform velocity is extremely rare because of several factors. Now see, if its speed is increasing, by what value the speed is increasing? In this instance you can see its initial velocity is 2 meter per second and final velocity is 4 meter per second. What is its change in velocity? 4 minus 2 meter per second in how much time? In 1 second time. So its speed is increasing by 2 meter per second in 1 second time, that is 2 meter per second square. Okay, in 1 second time its speed is increasing by 2 meter per second square. Okay, and this instance also its initial velocity is 4 meter per second, final is 6 meter per second, so its velocity is changing by 6 meter minus 4 meter per second in 1 second time, so its velocity is changing by 2 meter per second per second. Okay, so this value which we have just now calculated, this is called acceleration. Acceleration means the rate of change of velocity. If an object is moving with non-uniform velocity, then the rate of change of velocity, that is change in velocity per second time, per unit time, is known as acceleration. So we can define acceleration as, acceleration is defined as the rate of change in velocity. Okay, if the velocity is decreasing, that is also possible. As I told you, vector quantity can have positive, negative as well as zero value. If velocity is increasing, then value of acceleration is positive, but if velocity is decreasing, then value of acceleration is negative. In that case, it is called retardation. Okay, the opposite of acceleration is retardation. Retardation is defined as the rate of not change but decrease in velocity. Okay, so it's mathematically you can calculate acceleration as final velocity minus initial velocity divided by time taken. Okay, you can write it like A equals to final velocity indicated by V, initial velocity indicated by U, and time taken is indicated by T. And its SI unit is here, SI unit of change in velocity is meter per second, and per time is second, that is, it can also be written as meter per second square. Okay, now use this relationship to calculate acceleration, to do some numerical. Okay, take out the question for numerical for today. Question number 1. A body is traveling with a velocity of 30 meter per second after 5 seconds. After 5 seconds, its velocity reaches at 90 meter per second. What is its acceleration? Okay, this is your work. Here you can see a body is traveling with a velocity of 30 meter per second. That means it is initial velocity. After 5 seconds, it is time, and its velocity reaches 90 meter per second. This is final velocity. Now use the relationship to find out acceleration. That is your work. Let me give you another question. Question number 2. A car is moving with the velocity 20 meter per second. By applying brakes, it stops after 4 seconds. What is its retardation? Okay, this also you have to try on your own. Here, a car is moving with velocity 20 meter per second, means it is initial velocity, and by applying brake, it stops. Stops means its final velocity becomes 0. Remember, it stops. Okay, it stops means final velocity is 0 and time is 4 seconds. Now I'll use the same relationship as previously to find out acceleration of this car. Okay, let's do another. Let me give you another question. Last question for today. A body. Okay, a body starts to move from rest. Okay, it starts to move from rest means its initial velocity is 0, remember. Okay, starts to move means initial velocity is 0, and it attains a velocity of 20 meter per second in 8 seconds time. Now find its acceleration. Okay, its initial velocity is 0, final velocity is 20 meter per second, and time taken is 8 seconds. Now I need to calculate its final acceleration. Okay, that much for today. We'll see you tomorrow. Today you need to do these 3 numericals, and I'll give you more questions in the group. Check your group messenger. Check your messenger group. This much for today. Thank you.